Hello students, how are you all? Hope you all are doing well. So today in this video we are going to talk about the third equation of motion. So in the previous videos we have already studied, we have derived the first and the second equations of motion. Hope you have understood that. Now related to that only, now we are going to derive the third equation of motion, which is also known as position velocity relation. So without any further delay, let's get started. So here we are having our third equation of motion, that is 2as equals v square minus u square, that we already know, that is final minus initial velocity. This same equation is also known as position velocity relation, and for this also we are having the same graph that we have used in our first two equations. Here also we are having in a y-axis we are having the velocity, and in x-axis we are having the time. Here you can see everything is same. The point O, point A to B, the distance means the body is traveling from point A to B. It is already having some initial velocity which is denoted by u, and as the object travels from the point A to point B, so B becomes the final velocity, and here we have drawn one perpendicular line towards the x-axis and we have named it as point C. And this point from B to C, now we have denoted as it the final velocity v. So now let us see how to derive this equation. Here you can see in this graph the distance traveled by the object. Here we are going to find the displacement of the object, how much it is traveling. So in this graph, the distance traveled by the object S, we are having one object S which is traveling from point A to point V and having an initial velocity already. Okay, now it is not starting from zero, it is already having some initial velocity. The distance traveled by the object S in time t moving under a uniform acceleration a. What is the uniform acceleration a? This slope. This is the slope which is showing the uniform acceleration a, is given by the area enclosed within the trapezium OABC. Now for finding the displacement, we have to find the area under the trapezium, that is OABC. This is the trapezium, and we have to find this area for finding the displacement of an object moving from point A to B in a given time, that is OC. Okay, so now let us start the derivation. Okay, so here we know that the S, which is the body which is traveling from point A to B, the displacement is the area under the trapezium. Area under the trapezium. Okay, that is OABC. OABC. And we know the values also, that is from O to A, that is the initial value, that is u, and from B to C it is having the value final velocity, that is a v, and we also know that O to C is the time. So let us see here, for finding the area of the trapezium OABC, we should know the formula for finding the area of trapezium. So what is the formula for finding the area of trapezium? That is what? Half into base 1 plus base 2 into height. So this is the formula for finding the area of trapezium. So what is the base 1 and base 2 here? Base 1 and base 2 in any of the trapezium, when we are saying base 1 and base 2, these are the two parallel sides of the trapezium. So what is the parallel sides of the trapezium in this graph? That is the OA and BC. These two are the parallel sides of the trapezium in this graph. So we will take a base 1 as OA and base 2 as BC. And what is the height? Which side is left now? This is the height. OC, we will take it as a height. So now let us put the values. That is half into OA plus BC into OC. Okay. Now we have done this much. Now we'll put the values of this all. So that will come into half into OA is u plus BC is v into OC is time. Okay, so till here we have got that the displacement is this. So we'll give this equation as equation number 1. Now we'll take the help of the first equation of the motion for arriving at our third equation of the motion. So what was the first equation of the motion? That is v equals to u plus at. And from here we will get the value of t. T will be equal to v minus u by a. Correct. So here we have got the value of t also. This we will name equation number 2. Now further we are going to put the value of equation 2, that is t, in the equation 1 here. So we will put in the value of t, this is final minus initial by a, we will put it here for getting our third equation of the motion. So let us put. Okay, so now let us see here. We are having the first equation, that is half into initial plus final into time, that is equation 1, and the second one, time equals to final minus initial upon acceleration, that is equation 2. Now we'll put the value, and this we have derived from the first equation of motion. This is the value of t we have got from there. Now we are going to put the value of equation 2, this t, in the equation 1. So now let us put it. What it will come as equals to half into u plus v into, in place of t we will put the value of what we have calculated, v minus u by a. Okay, so now by simplifying this equation we'll get this u will become u square. This is the formula of plus minus will be minus, so that will get us 2a, this is then v square minus u square, s equals to v square minus u square upon 2a will get. Okay, so we have got s equals to v square minus u square upon 2a. So by changing the positions or by bringing 2a this side, we'll get 2as equals v square minus u square. So here we have got our third equation of the motion. So here we are done. So this is all about the third equation of motion. We have derived it with the help of the first equation of motion, that is v equals to u plus at. From there we have got the value of t. We have put the value of t in the equation what we have got by finding the area of trapezium. Then we have calculated and we have arrived of getting the third equation of the motion. Hope you have understood this. Now we'll do some questions related to all the equations what we have done. So let us do some of the questions. Okay, so here we are going to solve the numerical problems of page number 109 and 1010. In this we will try to include all the three equations what we have derived. So let us do the first question here. The first question is that a bus starting from a rest moves with a uniform acceleration of 0.1 meter per second for 2 minutes. Then we have to find speed and distance traveled. So side by side we'll start writing. A bus starting from a rest. A rest means the initial is what? 0. Okay. Then and with moves with a uniform acceleration. Acceleration is what? A. And what is the acceleration? 0.1 meter per second. And for 2 minutes. That means what? Time. Time is equal to 2 minutes, but it is given in minutes and then we have to convert it into its SI unit. We will just multiply it with 60 and we will get 120 seconds. So time is 120 seconds. So T is given, U is given, A is given. So according to the first equation of motion, it says that V is equal to U plus AT. We have U, we have A, we have T. What we have to find? Speed, that is V. So let us put the value. V equals to what is? U is O, acceleration is 0.1 and the time is 120 seconds. Understood? So by just solving it, how much we will get? 12 meter per second. So what is the speed? 12 meter per second. So we have found the first one. Speed we have got, that is 12 meter per second. Now we will solve the second part, that is distance traveled. Okay, so now let us find the second part, that is the distance traveled. What is distance? Distance is s, that we have to find. And other values we have u equals to 0, t is 120 seconds, acceleration is 0.1 meter per second. Okay, so now in the second equation you have seen s is equal to ut plus half at square. This is the second equation of motion. So we have to find distance and other values we have. So let us put u is 0 and 0 multiplied by 120 seconds will be 0 only. So 0 plus half, acceleration is 0.1 into t square, 120 square. So when we are going to find this, it will become, the square of this will become this much, 120 square will become this much, 12 square is 144 and 0 will be, so this is the 120 square into 0.1 upon 2, this 2 will come below. So after solving this, we are going to get 720 meter. Okay, so this is the distance traveled. So 720 meter is the distance traveled by the bus. So here we have got both the parts. Now we will do the second question. So let us find the second one. Side by side we will write also. A train is traveling with a speed of 90 kilometers per hour. It is already traveling, means having initial velocity. So we will directly write u equals to 90 kilometer per hour, but it is in a unit kilometer per hour. We have to convert it into its SI unit, that is meter per second. So how we will convert it? We will just multiply it with 5 by 8. So here we will get how much? 25 meter per second. So u we have got 25 meter per second. Then brakes are applied so to produce a uniform acceleration. The uniform acceleration is produced. So a is equal to, it is retarding, so it is coming in a minus 0.5 meter per second. Okay, then find how far train will go before brought to rest. Means it is going to some point and coming in the position of rest. Rest means the final velocity will be 0. It is coming to the rest. So final velocity will be 0. So v equals to 0. So what we have to find? Find how far train will go before brought to rest. How far? That means we have to calculate the distance as that we have to find. Here we are going to use our third equation of motion, that is 2as equals to v square minus u square. So for finding s, we will do s equals to v square minus u square upon 2a. Okay, so just we'll put the values. V is what? 0. So 0 square. Then minus u is 25 square upon 2 into minus 0.5. Okay. So by solving, what we will get? S equals to 0 is there. So directly we will write 25 square. Then 5 2s are 10, so it will become 1. So 25 square is 625 meter. 625 meter. So the distance will be 625 meter. So here we have solved the second answer also, second question also. So in these two questions, we have applied all the three derivations what we have derived of equation motion, that is equation 1, equation 2 and equation 3. Hope you have understood this. Now the other questions are there that you have to practice, and if you are having any doubt, you can ask. Okay students, so this was all about the today's video. Hope you have understood this all. And for this you have to practice it again and again for the better understanding, and you have to practice the questions also. In our next video, we'll be dealing with the uniform circular motion. So this was all about today's video. Thank you.